પ્રિન્સિપલ 1 એ કહે છે કે
Both
બોટનિકલ
are
નોમેનક્લેચર અને ઝૂલોજિકલ નોમેનક્લેચર બંને સેપરેટ છે, બંને જુદા છે, સ્વતંત્ર રીતે કામ કરે છે. અને જ્યારે આપણે કોઈ એક નામ વનસ્પતિ શાસ્ત્રમાં પણ આપ્યું હોય અને એ જ નામ ઝૂલોજીમાં હોય એનો કોઈ વાંધો નથી, પણ વનસ્પતિ શાસ્ત્રમાં એ જ નામ ફરીથી અપાતું નથી, એ આપણે ખાસ જોવાનું છે. એટલે વિધિન ધ અવર ગ્રુપ પ્લાન્ટ ગ્રુપ એ જ નામ ફરીથી મોરસ નામ હવે બીજા કોઈ પ્લાન્ટ્સને ન આપી શકે, પણ મોરસ તરીકે કોઈ બર્ડ ઓળખાતું હોય તો એ ઝૂલોજિકલ નોમેનક્લેચર થી આપણે સ્વતંત્ર હોવાથી આપણે પહેલા પ્રિન્સિપલના આધારે એનું નામ આપણે કેન્સલ નથી કરી શકતા, અથવા આપણું નામ પણ મોરસ કેન્સલ થતું નથી. અને એવી જ રીતે આપણે બહુ ફાઇકસ અને ફિગનું બહુ સુંદર ઉદાહરણ આપ્યું, અને ફિગને આપણે પ્રાણી તરીકે પણ એક ગેસ્ટ્રોપોડ છે એને પણ ફિગ તરીકે ઓળખાય છે, ત્યારે બીજી તરફ આપણે બહુ જાણીતું ઉદાહરણ છે અંજીર, એ પણ એ ફિગમાં કુળમાં આવતું હોય છે, તો એ પણ એવું સુંદર ઉદાહરણ છે. એટલે પહેલો પ્રિન્સિપલ એવું કહે છે કે બંને સ્વતંત્ર રીતે કાર્ય કરે છે. બહુ સુંદર રજૂઆત કરી. તો હવે બીજો પ્રિન્સિપલ કઈ હોય?
Let us go to the second principle. Look at the slide. What the principle says: the application of the names of the taxonomic groups is determined by means of nomenclatural types. Yes, here the word nomenclature type is very important. Yes, whether it is a species, whether it is a genus, these are all called as taxonomic groups. And whether it's a species or a genus or a family, an order or a particular class, these are all called as taxonomic groups. Each and every taxonomic group should have a name, and there should be only one name. And once a particular name is given, we should not give the same name to any other taxonomic group. That is very clear. And this particular name is to be determined by nomenclatural type. Now we have to go further in details. What are these nomenclatural types?
હા, એટલે આ બીજો સિદ્ધાંત એવું કહે છે કે દરેક ને નામકરણ કરીએ છીએ, પણ નામકરણ માટે નોમેનક્લેચરલ ટાઈપ એ બહુ અગત્યનું છે. એટલે મને લાગે છે આ નોમેનક્લેચરલ ટાઈપને આપણે વધારે ડિટેલમાં બતાડવું પડશે, કારણ કે એ શું છે પહેલાં તો આપણે એ સમજીએ. નોમેનક્લેચરલ ટાઈપ વિશે આપ જરા કહેશો કે?
Right. Nomenclatural types are nothing but there are certain elements which are associated with the names. When we have given a name, there should be some basis, and that particular base is called as a nomenclatural type.
Correct.
And it may be the actual specimen, or it may be a name of certain taxonomic group for depending upon the different group. And the what you say, ascertaining this name to a particular group and attaching with a particular element to a particular plant group name, that process is called as a typification.
So typification વિશે આપ જરા કહો.
So these nomenclatural types, the definition, by definition if you go, the nomenclatural type is a particular constant element of a taxon to which the name is permanently attached when a correct name, whether it is a correct name or a synonym. So that means as long as a plant name is existing and the basis should exist, the base should exist
on which
it is the base on which the name is
given.
Whether the name today it may be considered as a right name, correct name, but according to certain reasons tomorrow it may be proved as a wrong name. That means it may be reduced to the synonym. But even for the synonym, for the wrong name also, once you have given a name today, that means for that particular name there should be a basis, and that basis is called as a nomenclatural type. Okay, so then let us go for one by one.
Next slide.
So in the case of these nomenclatural types, for example, for about it is a species. For a species, the nomenclatural type is nothing but one specimen, exact specimen. When I say the specimen, it is a herbarium specimen. The students must be aware that the herbarium sheets or herbarium specimens are prepared in a particular standard size, and they are properly treated and they are properly dried. And when you say that today it is Saraka Ashoka, Saraka Ashoka was described long back in 1753. And even today also, if you see the type specimen which was designated at that time, it is existing and it will be existing. Even by chance, suppose if it is lost, then in that place another material will come. So as long as you use any botanical name, and that should be based upon a nomenclatural type. And if it is a species, it is a particular specimen. Yes. If it is a genus, then among different species, for example, if you say hibiscus, Hibiscus is the genus name. And this hibiscus must be having a different species, more than 100 species. And among the 100 species, the author of the person, the author of this particular taxon must have selected one species as a nomenclature type of the hibiscus. So it is an element. There it is not the exact the specimen. Right.
It will be considered
So
as
that
an
means
element.
it is that the element in the sense it is the name of the species. Yes, it is like
Correct.
that.
So there may be several kind of a nomenclatural types. So specimen, if we consider it is, so students know that holotype, scene type, type.
You are right.
So there are several other various kind of types, nomenclatural types. So shall we discuss?
Let us go one by one.
for that?
Let us go one by one. Slide.
So here is first we will discuss about the holotype.
Right.
What is holotype actually?
Holotype is nothing but the specimen or any other element used by the author of the name who has designated, and the nomenclatural designated this nomenclature type at the time of original publication. In the sense, I will elaborate it. When a particular species is found as a new species, then the scientist, the author of that name, that means he will have to publish that name. So at that time, he will designate a particular specimen, herbarium specimen, as a nomenclatural type.
Correct.
And that particular specimen, single specimen, will become holotype.
Okay.
It cannot be more than one specimen.
Okay.
Okay.
That original specimen on
Original
which
specimen.
that he described and he designate it as a nomenclatural type.
Exactly.
So that is known as a holotype.
Holotype.
Correct.
And as long as this, as I said, that as long as this holotype is exists extant, then it is permanently attached to that
particular
element application of the name concerned. Yes.
જો અહીંયા કહ્યું છે પ્રમાણે કે જે નમૂનો કે લેખક દ્વારા સચિત્ર વર્ણવેલ ઉદાહરણ તેમના દ્વારા તેને ટાઈપ તરીકે ઓળખાયું હોય એને આપણે હોલોટાઈપ, હમણાં રેડ્ડી સરે કહ્યું પ્રમાણે આપણે ઓળખાવશું. ત્યારબાદ બીજો કોઈ ટાઈપ છે એની વાત કરો.
Yes, definitely. For example, you have designated one specimen as a nomenclature type and only one specimen for species, then it is known as a holotype. By chance it is missed, then what will happen? There will be several issues will come up. So in that case, generally what the scientists, these systematic botanists, they do, when they collect the samples, they do not restrict with only one collection. They will collect in duplicates, in triplicates, in several multiple samples. Why do they do? Yes, when they go to the field for collections, then if they collect only one plant, there is no guarantee that in course of time it may be attacked by the fungus, it may be attacked by the insects, it may be dampened, or it may be when it is stored, rodents may spoil it, or sometimes when the specimens are stored, fire accidents may damage this, floods may damage. So therefore it is recommended and it is general practice that they collect not one specimen, they collect in many cases
more than
specimens, and these specimens are stored at different places.
Okay.
At different places.
They are not at one place.
Mostly they are not at one place.
Fine.
Right. For example, the holotype is created. It is stored at one place, a central national herbarium, which is in a government herbarium. Suppose if it is kept, then the other collections may be kept in different herbaria, maybe within the same country or maybe within other country also.
So what is isotype then?
Yes.
Then what?
Right.
If it is stored somewhere else, then
yes,
what is isotype?
Exactly. Now, just let us concentrate on one example. Visualize an example. Suppose we have collected one plant as a species, a new species. Then you have given a name. You have designated one specimen as a holotype. Then whatever the collection when you did it in the field, as just we have discussed, the field collector will be collecting number of other samples. On the same day, from the same locality, you must have collected some other plants belonging to the same species.
Okay.
So those specimens, except one which you have designated as a holotype, then all other samples will become isotypes.
Isotype.
That means in short, isotype is nothing but the duplicate of the holotype.
કે અહીંયા સ્લાઇડમાં વ્યાખ્યા બતાવે છે કે આઇસોટાઇપની વ્યાખ્યા કે એ હોલોટાઇપની બીજી નકલ રૂપે હોય
નકલ રૂપે.
એમ આપણે ગણી શકીએ.
Right. It is characterized by the same, that means it is collected, it bears the same collection number by the same collector from the same place at the same time. These are the things.
Okay.
Isotypes.
આઇસોટાઇપ્સ.
Right.
બીજું
It is not necessary that always isotypes should exist.
બરાબર.
Okay. But generally, it is preferable to have isotypes.
ઓકે.
Sometimes it may happen that you go to the field, you collect some specimens today, and you do not describe it as a new species today. Maybe in the next year you may describe it, because today when you collect it, it is not in all stages. It may be only in vegetative condition, it may be only in flowering condition, fruits are not present. So therefore you keep the specimens, you bring the specimens to the laboratory, you make herbarium specimens, and you store it. Next season, next year, when you go there, if it is found in the fruit condition, once again you collect it. Or otherwise, your co-teachers, your co-students, maybe in some other area, they may be collecting from different areas. So all the specimens we must have got for observation. So before describing your name of the species, you have got a good number of species in front of you. One is the specimen which you have collected and designated as a holotype. That is a holotype, one specimen is gone, and the rest of the duplicates of that specimen
of
that
the
has
same
become
time, of the same collection,
right,
same date collection,
right, that has become
Isotype.
It may be one specimen, or it may be many. Right. Rest of the cases, parallel collections which are in front of you, which you have seen before describing. And they are mentioned, they should be mentioned at the time of publication.
Okay.
And the first publication of the name is considered as a protologue.
Okay.
So if these specimens are mentioned in that protologue, and they can be considered as a parallel collections, and these specimens are regarded as paratype. Just now look at this slide. Paratype.
એ નમૂનો કે જે પ્રોટોલોગમાં નિર્દેશિત કરેલો હોય, પરંતુ તે ના હોલોટાઇપ હોય કે આઇસોટાઇપ હોય ને સીન ટાઇપ હોય. આ બહુ સુંદર રજૂઆત કરી કે નમૂનો વિદ્યાર્થીઓ દ્વારા અથવા રિસર્ચ દ્વારા અથવા પોતાના દ્વારા પણ એ જ સમયે કલેક્ટ ન કર્યો, પણ એના થોડાક સમય પછી કે જેમાં વાનસ્પતિક અવસ્થા સિવાયની અવસ્થાઓ કદાચ એને પછીના નમૂનાઓમાં મળી હોય અને તે વખતે એને ડિસ્ક્રિપ્શનના એમાં સમાવેશ કર્યો હોય, એટલે એને પ્રોટોલોગની અંદર પણ એનો ઉલ્લેખ કર્યો હોય, તો એવા નમૂનાને આપણે પેરાટાઇપ તરીકે ઓળખાવવો પડે છે. બહુ સુંદર. ત્યારબાદના કોઈ એવી કોઈ ટાઈપ હોય એના વિશે?
Right. Now, before going to the next type, let us see the examples.
Slide ma examples batao.
Examples. Just you read on this slide. See, there are two scientists, Shetty and Vivekanandan. They have collected a plant and they have described as a Vernonia anaemudica. It is collected from the southern part of India. So the Shetty and Vivekanand have become the authors of this name, not the species. The scientists, they never become authors of the species. They become the authors of the name because they have given this name. Okay. So while giving this name, what they did it, they have given the name and they also published it in Bulletin Botanical Survey of India, volume number 12, in page number 268 in 1972. So in that protologue, they have clearly mentioned that holotype, the collection number Shetty and Vivekanandan 31786. Okay, then the duplicates of this Shetty and Vivekanandan 31786 B to Z, and the parallel collections 26546 A to E. These are all some more collections are also there. And suppose if by any reason the author has not very specifically, very categorically did not mention one specimen as a holotype, then there may be many specimens. If he described at that, these are all type materials. Sometimes, it may happen that suppose the plant is small and in the standard size of the herbarium, you may put, more number of the plants.
Yes.
And if you do not designate within that one specimen, then all other materials will become syn types.
Okay.
Syn types. Because here holotype is not designated. more number of specimens are present.
Available.
So therefore they become SIN type.
Okay.
Under such circumstances, we should not leave the situation like this.
હા.
So if you realize that there is a SIN type is existing, then you have to select one material,
Out
one
of that SIN
specimen
type.
out of these SIN types, okay, to serve as a nomenclatural type.
Okay.
Okay, under such circumstances, that particular specimen is considered as a lectotype.
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 Good.
Now let us see on the slide what is the SIN type. SIN type is nothing but any one of two or more specimens cited in the protologue when no holotype is very specifically categorized.
બહુ
Or
સરસ.
sometimes one of two or more specimens are simultaneously designated as types in original description. That is called as SIN type. So under such circumstances, then SIN type you want.
તો સિનટાઈપ સરે કહ્યું પ્રમાણે હમણાં આપણે બહુ સુંદર રજૂઆત કરી કે સિનટાઈપ એટલે કે પ્રોટોલોગમાં સમાવાયેલો હોય પણ આ આપણે કહ્યું પ્રમાણે કે એક જ હર્બેરિયમમાં અથવા કલેક્શન ઓફ દેટ પ્લાન્ટમાંથી કોઈ એને ડેઝિગ્નેટ ના કર્યું હોય કે આ હોલોટાઈપ છે તો એવી અવસ્થામાં જ્યારે બધા જ નમૂનાઓ હોય એને આપણે સિનટાઈપ તરીકે લેવાનું ને એમાંનો એક સિલેક્ટ કરવાનો છે જે આપણે હવે પછી બતાવવાના છો અને આપણે કહ્યું એ પ્રમાણે લેક્ટોટાઈપ એમાંનો એક આપણે ટાઈપ સ્પેસિમેન તરીકે નોમેનક્લેચરલ ડેઝિગ્નેટ કરવો જ પડશે તો એવી અવસ્થામાં આ નમૂનાને આપણે લેક્ટોટાઈપ પણ કહીએ
That's
છીએ.
right.
Good.
So when we say that the holotype is not designated, or holotype by chance it is destroyed, it is missing, then naturally we have to select a particular specimen to serve as a nomenclatural type. In such circumstances, as I said that if isotypes are present, then you have to select from the isotype.
Isotype.
Suppose if isotypes are not there, then by another second chance what I said that if holotype is not designated, SIN types are present, so you have to select from the SIN
SIN
types. Suppose isotypes are not there, okay, then SIN types are not there, then you have to select from paratypes.
Paratype.
Suppose even paratypes are not there, okay, so if at all you are selecting a specimen either from the SIN types or from the isotypes or from the paratypes, such an element is called as a lectotype.
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 Good.
Okay. Suppose even that means there are no SIN types, there are no isotypes, there are no paratypes. If at all they are present, they were also missing, they were
Missing.
destroyed. Then under such circumstances, what will happen? Then again, as I said that as long as the name is there, the base of the name should be there as an
Okay.
element.
Ha.
So therefore, there should be immediately there should be one specimen
To be designated over there.
Yes.
And what is
And
it is called as?
such type of condition is called as neotype.
Neotype. Okay.
Okay.
જ્યારે આ અવસ્થામાં કે જે બધા જ પ્રકારના નમૂનાઓ ઉપલબ્ધ જ ન હોય અને એ ઉપલબ્ધતા ન હોય તે વખતે મને લાગે છે કે ફરીથી રીવિઝિટ
Yes.
કરવી પડતી હશે
Yes.
અને ફરીથી એ કલેક્શન એ ચોક્કસ જગ્યા